Hello, welcome AusIOTers. I'm developer Ali from IBM. I would just like to welcome you all to our venue tonight. We also have joining us the awesome Michelle. She's live in Bruce, as I like to call it. Hi, Michelle. So I think you were going to share your slides, Michelle, or did you want me to do that now?
I think we're sharing.
I can't see your slides. So, oh, here we go. All right, amazing. Okay. So just before we get started, guys, and by the way, thank you all for joining us. I'd like to begin by acknowledging the UN people, who are the traditional custodians of the land on which I'm gathered here in beautiful Jarvis Bay. Lucky me today. And if you know the people whose land you're gathered on, please put that in the chat for us. And I'd also like to extend that respect to Aboriginal and Torres Strait Islander peoples here today.
All right. Can you hear me and see my screen and see me okay, Developer Ali? Yep.
We're going well.
All right. So I'm Michelle, everyone. It says here Todd Whitehead, but that's okay. Todd's over there. I'm Michelle. I'm the developer advocate for Telstra. It's nice to see you guys. And I'm here in the room with a crowd of lovely people. We've got about 15 to 20 people within the room here. We're gathered on the Turrbal Nation, which is north of the Brisbane River. Yeah, north of the Brisbane River. Some people here today may have come from south, which is the Yagara lands. I myself came up from Ugambe lands in the Gold Coast, but my heart is originally down in the Ghana land with the Adelaide people. So in the spirit of reconciliation, I want to recognise all of those lands and all of the lands I see popping up in the chat there, which is great. I see another Ghana land person there as well. And we recognise and respect the cultural connection that the First Nations people have to this land. And I just want to acknowledge that the sovereignty of these lands have never been ceded, and we're pretty grateful to be on this land, but also recognise what's been lost to have us here today. So great to see some more Ghana people there dialing in the chat. So on that note, reconciliation, starts with truth telling. So I'm glad that we'll all be able to share that today. On that note as well, I hope you've all been safe from all the crazy things going on in the world at the moment, including we're just talking about some disruption with content delivery networks lately, Akamai and Fastly and things like that this week, but that's the least of our problems at the moment. So just for the agenda for tonight, so there's people here on the Remo platform. I see about 13 people dialing in. Again, we've got about 20 people in person. If you are here in the room today, the toilets are just outside. Guys are to the right, and I'll go to the left. We also, if it's an emergency, head out towards the female toilet and down the stairs, and then we're crossing over the river to gather together, but that won't be an issue. Ali and I are going to talk about some of the events in the IoT space that are coming up soon. And then, because we are here in the Microsoft office, we've got some Microsoft speakers today to talk about DevOps. We're joined by Todd and Val. And then we're going to have a fireside chat, a virtual fireside chat, get nice and cozy with Massimo from Arduino. And he'll be joined by DeveloperSteve later as well to talk about the new Arduino Pro program that they've got. Then we'll open up at the end if anyone wants to stand up in the room or put their hand up in the Remo chat to share something they're working on. So I just did a pulse check in the room. We've got a great mix of people here. We've got some developers, some engineers, some people who are just interested in technology, which is great as well. People that are in corporates or in small businesses or with their own companies. So if any of you want to share something at the end after the two speakers, I welcome you too. We're going to have a break in the middle between the two speakers, and then another break at the end where we can hang around in the room, and the virtual room and the physical room until 8 o'clock, just catching up and meeting each other because it's been a hot minute. It's been a while. So thank you to Microsoft and especially Val and Todd and Georgina for having us here today. It's very special to be able to be in person. We really, really appreciate that. And I'll hand it back over to Developer Ali to talk about the virtual venue, which is also very important.
Yeah, thank you, Michelle. So I think everyone's maybe seen the virtual venue before, but if you haven't, we're using this platform Remo. Basically, you can jump around the tables and talk to other people. Obviously, it's like most virtual, programs you've maybe used before. You can turn your mic and camera on, you can share slides, that sort of thing. Maybe one of the differences is if you do have questions when the speakers are on, feel free to put them either in the Q&A or even in the main chat, and we'll make sure to ask them. And any other problems or questions or issues, please just, let me know and I'll help you out with those. So I think that's about it for today's video. I'm super excited about tonight. We have some amazing speakers, Massimo and the Microsoft crew. And we really love doing this hybrid event. Well, I love it particularly. I know a lot of people want to be doing in-person events now and actually seeing each other again after all this time. So that's awesome. But I actually love the opportunity we have to, still bring together everyone that's in a similar time zone to hear these kind of things, which is super cool. See, there you go. We've even got someone listening while driving home. On speaker in the car. Now that is high tech. I love it. I love it. So code of conduct, guys, just a little bit of a reminder, although you all probably don't need reminding. We're an inclusive, friendly, diverse and respectful bunch. So please make sure to, act appropriately, and, every idea and is a good idea, and, discuss as an adult, like we all are. So I'll hand it back over to you, Michelle, to introduce, is it our speaker I think we've got next? Oh, sorry, upcoming events. I've lost the schedule. Also, thank you to our other hosts. So I'm Developer Ali from IBM. We host this virtual platform. So thank you to IBM for paying for that. Obviously, thank you to Michelle for always organising these amazing speakers to have as well, and to Snyk.io, who, well, DeveloperSteve's an advocate for Snyk.io now, so thank you to Snyk for also helping to organise this event as well. We appreciate you all. So upcoming events, I've just got one that I want to quickly mention, and that's Call for Code 2021. So for those of you that may not know about Call for Code 2021, it's a global challenge. It's focused around finding answers for climate change. There's three main themes we're running this year: zero hunger, responsible production, and I have temporarily forgotten the other one, but clean water and sanitation, that's it. So it's open until July 31st. So if you do have an idea around, or something you've been tinkering with around one of those things, we've had actually some great success with some IoT challenge solutions that have been submitted in the past. So we had one in 2018 and then another in 2019, Project Prometeo and Project Owl. That came first globally, and there's a $200,000 prize, as well as help from the Linux Foundation and IBM to actually deploy that solution. So those solutions have actually been deployed now. So if you are a bit entrepreneurial, or you do have an idea that you think would help around climate change and one of those themes, have a look at developer.ib for code. Really great initiative, and you'll get a lot out of it. So check that out. That's all I wanted to say about that one. And now I'll hand back over to the awesome Michelle, who has Todd and Valeriia with her, I think.
Yes, thank you. We've got Val and Todd here. I hope you guys can still see me and hear me. Yeah. Oh, yeah. Okay, cool. So Todd is a senior cloud solution architect with Microsoft over here in Brisbane. Like many of us all here, unashamedly a geek and a technology advocate, which is fantastic. So we're excited because Todd is an expert on IoT cloud architecture and DevOps. And as you can see, if you're online or in person, there's some fun, shiny lights going on here that we're going to be talking about. And the assistant here is Val, with a background in embedded systems and electrical circuit design. She's the IoT lead here at Microsoft in Australia, not just in Brisbane. Does that right? Yeah?
Well, New Zealand.
Australia, New Zealand. Don't forget New Zealand. Sorry, we're very inclusive. Yes. Val's also passionate, like what we're doing here today, about sharing technology and solutions. So I hope you guys learned something out of today's presentation, which is driving IoT innovation with DevOps. So ClickOps to DevOps in 30 minutes. I love that. And it's going to be combining the agility of cloud plus the security and reliability of on-prem. So I'm excited to see what we've got going on here in the room, and I'm glad that we've able to get the tech working, which is like great. This is the third hybrid meetup we've done together with AusIOT, and so far, I mean, fingers crossed, this has been the smoothest start so far. Thank you for being patient with us, but let's see how we go. So without further ado, I'll probably get Todd. Oh, no, don't take a break yet. I'll probably get Todd to come back on stage, and yeah, keep us going, keep us rolling.
Awesome. Thank you, Michelle. Feels like IoT hot seat. It's let me just switch over. Okay, excellent. So thank you, Michelle. So yes, as Michelle said, my name's Todd Whitehead. I came from a developer background, but I've learnt the error of my ways, and I'm now a cloud solution architect here at Microsoft. So I focus on DevOps, IoT, and cloud native apps, and I've been lucky enough to sort of work with quite a range of customers, go down the big mine sites in Salt Lake City and Mongolia and all those kind of things, and actually see those real world problems that we developers kind of like to think about. But then, yeah, when you see it in reality and you start to understand some of the challenges of rolling out these IoT solutions, it's quite an eye-opener. So that's kind of my day job. But when I'm left unsupervised, I guess would be the best way to put it, I like to come up with strange and difficult ways to make those things work. So these are a couple of memorable, I guess, demos I've done that took years off my life. But the top left one there was using Azure DevOps to commit code on my laptop, have that go through a DevOps pipeline, and deploy to a Commodore 64 live on stage at NDC. So that was a little interesting, and that one was done using the IoT DevOps model, which is what we're going to do today. Other ones have been things like using custom vision servers, deploying that down to IoT devices so you can tell if the person next to you is a Cylon, and if they are a Cylon, which type of Cylon. So very, very practical things. So tonight, though, and in 30 minutes, we're going to try and cover just very, very quickly IoT and DevOps in terms of what's different about IoT and how can DevOps help, why do we even need it. We'll do a super quick speed run on a couple of the parts of the Azure IoT platform we're going to use. And then I'm basically going to just do a quick walkthrough on, okay, what does that look like when we're doing things in a ClickOps, clicky way? And then how could we possibly rub a little DevOps on that and see how we go. So what do we got? 20 minutes, plenty of time. So the thing I find most interesting and engaging with IoT is just how diverse the problem spaces and the domains and the challenges are. So obviously lots and lots of work around industrial IoT and those things, but then you start to think through to, especially what we've seen now with COVID, all the interesting scenarios that were probably thought not that important before or too challenging. All of a sudden being able to count how many people in a room, how far apart are people in a room, some very real problems that needed to be solved very, very quickly. So that's it's sort of changed a lot of the perspective on things. Equally well, to make those things happen quickly, we really need to combine the power of cloud-based technologies and edge-based IoT. That's both in terms of the services you can take advantage of, so the building blocks that are there, but also the ability to scale and manage and do all those kind of things when you need to do things quickly. So DevOps, just in general IT terms, is one of those, that we've now really got the data to back it up, that it does help drive that speed and agility. But they're very different worlds, right? When we talk about developers and ops, developers want to do things quickly. They want to use the latest and greatest. And ops, they're all about stability and control. And that's not dissimilar to, I guess, between what we see in the IT world and the OT and IoT world, right? Where, control, things need to be a lot more controlled. Tech stacks tend to evolve a lot slower. Lots of legacy protocols and challenges to deal with. And then on top of that, we've got to deal with all the problems of connectivity, both in terms of do you even have any versus how big is it, how often do you have it, as I said, lots of protocols and things like identity and security. Because I didn't put one in because I think we can just all assume, just picture in your head 100 IoT security horror stories, whether it's the temp sensor in the casino fish tank or the car manufacturer that put the secret key on the window that you needed to turn that car on and off. Plenty of examples. So that can lead to a little bit of conflict when people want to push out these IoT solutions, and then the people who actually need to run and operate those environments are kind of going in a nice way, probably nicer than Liam Neeson, you know, hang on a sec. So enter DevOps. So there's lots of definitions of DevOps. This is one we tend to use at Microsoft, kind of, I guess, evangelized by Donovan Brown. But it really focuses on people, process, and products, and the order is important there. The people are always the most important, process second, and the products or the tools last. But it's about delivering value to the end users. So not just delivering software. It's not about CI/CD. We don't just want to push more bits. We actually need to deliver value. So measuring that in an IoT world can be kind of interesting. But these are kind of the underlying things that are often part of that pipeline. These are the tools part. So that's what we're going to look at tonight, how we can do that in an IoT sense. So, you know, all the good as codes, the infrastructures, the configuration, but then particularly around integration and delivery and monitoring in a distributed way. So I dug back through my archive, and this was my first IoT demo I put together in 2005 in the room next door. And this is as sophisticated as cloud-based IoT was. So this was connecting up to a military flight simulator, collecting all the data about all the different objects and things in the battle space, and then writing some custom code which would suck that data in and push it up to an Azure Event Hub. So there was no concept of the IoT thing having an identity. It was just a magic string you gave it, and you put it through some stream analytics, you did some calculations, and you wrote it to SQL. And that was kind of what 2015 looked like in IoT. And this is kind of the Azure IoT platform in 2021. It's pretty amazing to see both the range and the depths of things. I mean, we're literally making our own hardware silicon now and licensing that out to people. But basically all up and down the stack. But we're going to focus very heavily tonight on one little component. So this is kind of the modern version of that flight simulator version, but we're really going to focus on the next 20 minutes on that part there. So this is the part around how do we actually take something we're deploying and push that down to some edge devices, and how do we manage that securely and do that in a reliable way. So really, just as a very quick level set, the core of the Azure IoT platform is the IoT Hub. This is the cloud gateway that controls everything we're going to do in our IoT ecosystem. So it's the thing that's responsible for managing identity for the devices, and even assigning specific identity to the pieces of software running on those devices. So you can manage down to that identity level. Whole lot of good functionality. And then the other part of our story, that's the cloud part. The edge part, we very, very cleverly called IoT Edge, because, you know, we have marketing departments that dream up names. So the Azure IoT Edge is a container-based platform because, you know, it's DevOps and it's 2021, so you know it's going to have containers in it. And we're doing DevOps, so you know you're going to see some YAML and JSON tonight, right? But basically what it allows us to do is package up our software and tell the IoT Hub which devices need which bit of software, and of those bits of software, which bits of software are allowed and can talk to each other. So we're going to orchestrate that whole process through the hub, and then the edge is where that's all going to run. And important to understand too that it's not just our own custom code. We can actually package up a whole range of Azure services and push those down to the edge. So everything from blob storage to stream analytics to cognitive services. Those containers are available and we can push those straight down as well. Okay, so the way this process works, and this is just to kind of set the scene for the mechanics you're about to see, is up in Azure IoT Hub, we're going to basically create the containers we need. We've got some with sample code that we've written, and we're also going to use some of the Azure services, but they then go up into a container registry. It can be anywhere. In this case, I'm using Azure Container Registry, because again, the marketing department went to all that trouble of coming up with such a catchy name for it. So the build process is basically, we push those up, and then we're going to create a deployment manifest. This is the file we're going to give to the edge device that's going to describe the state we want it to be in. So this whole model is a desired state approach. So we're going to create that file, say, hey, you need this module from this container image from this repository, and it's configured this way, and it talks to this, and here's the security, and here's all the things that go with it. And then we're simply going to push that down to the IoT edge devices. We can do that to one device, or really the scale, which is what we're going to see tonight. We're going to describe the characteristics of, or the properties of the devices we want to have this manifest. And the great thing with that is if we do this deployment tonight, these devices here will obviously get it. If I plug in tomorrow a new device that also has those same properties, it will automatically get that deployment. So we don't need to worry about redeploying because things weren't on. And that's really key in IoT scenarios where often devices are pulled out of the cupboard 6 months later. You want those to instantly get the latest configuration. So that's the kind of model we're going to go through. Okay, enough of these slides. Let's go and have a look. Okay, so I've provisioned all the infrastructure. Actually, let me come back here. So there's a few moving parts sitting up in Azure to support this tonight. So if I just load up my dashboard here, obviously we have the IoT Hub. The IoT Hub, which is the main thing we're going to use. But then we also have a few other components. We have a container registry, and then we have some other supporting things. We have some time series insights and all sorts of other little services we can drill. So we can also, though, if you're more of a codey type approach person, probably like most people, I spend most of my time when I can in Visual Studio Code. And all of the elements of the resources in Azure are equally accessible here. So we can see here I've installed the Azure IoT Hub extension, and here are the devices that I've created inside the Azure IoT Hub. So we can see a range, and I'm assuming for the people online can see Val's screen. Yep, perfect. So what we've got is 3 Raspberry Pis because it's IoT. All right, you have to have, it's the rule. You have to have Raspberry Pis for an IoT. Just joking, they're incredibly versatile things. So what we have is 3 IoT devices there, but they're actually doing double duty. They're operating just as a simple sensor. They each have one of the Raspberry Pi sense hats, which are great because it has 5 or 6 different sensors on it, as well as that cool little LED screen and a whole bunch of inputs and things. But they're also running the Azure IoT Edge runtime because it can run on, it's open source, can run on a whole bunch of platforms. As long as it can support Docker or Moby type runtime engine, it can support it. So they're going to be our little devices. And then we also have a couple of larger devices. So these Pi edges are our edges. I have my little Odyssey, the little blue box up here, which I really love using because it also, it's an x86 based system, but it also has an Arduino built into it. So you can actually do both things at the same time, which is really handy. So that's going to be our Ring 0 device. And somewhere here, I also have a little Intel NUC, and that's going to be our Ring 1 device. So you can see those there. Now, what you might also see, and we'll see what these come from later, you'll see these other devices which have really unfriendly names, as they tend to do. So they're the things that are going to be built automatically as part of our pipeline. We'll have a look at those. But if we come down and just pick one of these devices, where's my, oh, that's, just realized why it's having really hard time reading. We'll just keep that, people online don't need to understand that I did have my glasses. Okay, so if we, for example, take the Odyssey 1 device here, we can see here's the modules that are deployed. So each of these modules here is one of those little Docker containers that are running. And it's running the one with the dollar signs there. So the Edge Agent and the Edge Hub. They're the containers that Microsoft provide to manage that environment. So that Edge Hub is the thing that's going to run out and pull down our deployment agent, handle all the communications. If the device goes offline, it will buffer those all up and deal with that when it comes back online. And the Edge Agent is the thing that actually looks after all the other modules. Is everyone healthy? Do I need to restart that module? It'll take care of all that for us. And all these other little modules here are the ones that are running on it. So we've got, this is one of our reference ones, a little module just generates simulated telemetry data, and I can right-click on right-click on that one, and we can get all the different information we want about that particular module or that particular device. We can also come in. Oh, there we go. Come on, up you come. And you can see here we can also start monitoring the actual telemetry coming off it. So right here in Visual Studio Code, I can do all this clicky, all good. If I wanted to create a new deployment of modules to go out to this device, I can literally right-click on that and do all these things, including create deployment for this device. So that would then allow me to manually put together a file that describes what needs to happen. We're not going to do that. So we'll have a look at one of those, what one of those looks like. Come on. So it's JSON, so we haven't got to YAML yet, so we haven't got that far into the DevOps world. But basically, it's a pretty straightforward file. It just describes each of the modules, what they do. Because we're pulling container images, they need some credentials for those containers, for that registry rather. And then if we come down here, a couple of these we'll see. Oh, yep. So most of them don't have any special configuration, but you'll see some do have these create options. So because these are containers, they're obviously running in the sandbox of the container runtime, but sometimes you need access to things outside that world. So in this particular case, it's mapping some ports. But for example, I've done other things on the Odyssey where I've got actual sensors connected to the GPIO pins. Therefore, I needed to grant the Docker container some elevated privileges to do that. But we can capture all that inside the configuration file. So that's for the overall deployment. And then each individual module, when you're building it, has a file as well. So literally, it's just like building any other Docker container. So any sort of container-based system, that all kind of works together. And obviously, you can build that out for all sorts of different platforms, because even here tonight, we've got both x86 and ARM-based systems. So we need to take all that kind of good stuff into account. So these are all the kind of things we can do with devices, creating and deploying and doing all those kind of good things, either in a ClickOps way, either through the something like Visual Studio Code, or if we jump back over here, or through the Azure portal itself. If I came into my IoT hub, all the things that you've sort of seen there, we can do in here as well. And lots and lots of things. So you can see here we've got our IoT Edge. Oh. Sorry, there's a slight lag. While it's loading, but you'll also notice over here on the left is all the sorts of things you can do, including, we're going to have a look at a bit later, and the metrics and all those kind of things. But lots and lots and lots of interesting functions you can do there. It's gone slow. That's okay.
Probably freaking out having a screen share.
Yeah, there's a definite lag. It's like that thing when your voice is echoed by delayed by half a second. It's freaking out. That's good.
I might have missed it, but are you managing the base operating system as a module as well?
No, we're not.
Just repeat the question.
Oh, sorry, yes. So the question was, are you managing the base operating system on the devices as well? And the answer is no. So this is running on top of the container runtime. So we're managing from the container, on this case, on the container level up. I will show you later what we are doing though. One of the containers that was deployed was called something metrics container. And what it's actually doing, it's actually monitoring the underlying operating system. So it's looking at disk space and memory usage of the actual underlying host, so it can detect problems as well as that. So in this particular, if I jump back to VS Code, because I had to provision all these devices, and because not everything can run in the cloud necessarily. So for example, to configure those devices, there's about 6 different steps you need to install the IoT Edge components on. You need a container runtime, you need this, you need that. But rather than do all those, I've used Ansible. So I've just put together the little Ansible script here, which I can run and just say, go on all the Raspberry Pis, make them look like this. So it's something that's happening outside of the workload deployment, but it's certainly something that can be managed in a way like that, rather than either explicitly scripting or going and doing some, again, connecting to each one and doing all the kinds of things. So we can start to introduce those. Cool. So let me quickly jump back because I want to get to the DevOps part. Oh. Okay, I'll do that. Okay. So that was super quick. So now we need to figure out a way to rub a little DevOps on that. And this is the DevOps model we publish. And this does work as well for Commodore 64s if you ever need to do that. So at the most simplistic level, imagine we have a developer. Okay, now, and again, remembering that I said, as well as custom code, this can also just be deploying Azure services, AI models and things you've trained in the cloud. It can be anything. But in this case, I'm using Git on Azure DevOps, but it doesn't really matter. It's using a source control system of some kind. But the idea here is we have a development branch, which we create a branch off for ourselves. We do our development, we do our stuff, we do our little local testing, and then at some point we're going to be ready to merge that back as a pull request to our development branch. So, in a typical IT or software project, that would then do some continuous integration and do some testing and do whatever. We're going to do exactly that. So we use that exact same mechanism of a pull request. And what we're actually going to do is we're going to take that container and we're going to deploy it in the cloud to a simulated device. Okay, so we're going to do some testing on it. We're going to keep doing that, and then at some point we're going to say, you know what, we're ready for this to go, to the next step, to production or to get ready for production. So we're going to come back to the higher level branch, the master branch, the main branch, and then again triggering off that pull request, we're going to run another pipeline, both testing and deployment, and that's what we're going to have a look at now. So that's the idea. And the idea here is, again, we're going to do some stuff in the clouds as much as we can, but obviously we don't have the real devices in the cloud, so there's limits to it. But we're going to smoke test the deployment. We're going to do some integration testing. We're going to do some load testing, and only once all that is ready are we actually then going to push it down to those devices. And then I'll show you we're going to have a way to then roll that out progressively using a ring system. So we don't just push it out to our million devices, we actually manage that process. So let's quickly look at how we do that. So I'm going to jump over here to Azure DevOps. So I have, I should show you that. So I have my code repository here, which is where I'm pushing all my changes into. There we go. Come on, you can keep up. Okay, so here's that that code we saw before, and one of the things to note, if we go and have a look at the code for the actual solution, in that deployment template we looked at, you'll notice that once it loads, rather than have hard coded the credentials here, we've just got some placeholders that we're going to replace that with as we go through the DevOps pipeline, both at the deployment level and for the individual module as well. Because unlike if we're just building a web app, that'd be nice and simple. In reality, we might need to do different builds depending on the architecture we're deploying to, depending on the device. So we might need to do this actually multiple times depending on what the scenario is. So here we have our CI build. We can see here, this is pretty straightforward. This is, all right, who's watching Netflix? Come on.
Yeah. Share your screen, share your video.
Yeah.
I have a question in the chat, and just to remind, if you want to remind everyone to keep putting questions in the chat, and we'll do them at the end. Okay. Yeah.
Just a reminder to everyone, please keep putting your messages in the chat, and we will get to them at the end. Wow, this is running slow. There we go. Okay, so this is our CI build. So this is when we've checked in our first code. Okay, and we can see here that it's done a number of steps here. So obviously it's just checked out the code. Now, one of the important things in here, we're going to have to start putting in things like container registry keys. So these are secrets. These are not things we want in the source code repository, and we don't really want them even in the build pipeline themselves. So what I actually have here is a task. I'm using Azure Key Vault, which is a HSM-backed secret, super secret, cartoon-style secret safe. And at build time, I'm going to pull in those secrets and then inject those into those values. So they're not stored in the pipeline, they're not stored on the thing, and they'll only be pulled in when they need to. We do our token replacement, you can see all that, and we basically build out that thing we need and push that up into the container registry. So the CI is pretty straightforward. Where it gets really fun is more in the CD. So these are our actual release pipelines. So this is that second part where we're now going to merge that and say, okay, we're ready to release that. So let's go and have a look at what that looks like. Come on, you can do it. The demo gods are cruel. Yeah,
There
well,
hasn't been as many people in the office for over a year, so.
yeah, I don't know if that. I still think it's the Broncos' fault, but I can't quite figure out how. Oh, okay. There we go. Thank you. So here's those steps we're going to do. So first, we're going to create a deployment now, which again is pulling in just mainly those values again for the environments we're going to deploy to. So I'm scared to do this, but there we go. Come on. Thank you. So you'll see the basic set of steps here. Again, I'm pulling in the values from Key Vault because I don't want any of those secrets to be thing. We're going through and replacing in that overall deployment template, as well as replacing them in the individual module because that might have some parameters. And then there's a built-in action here you can call to do this IoT Edge things. And the good thing is there's equally well, just through the Azure CLI or through a REST interface, you can do that as well. So I'm doing it here in Azure DevOps, but realistically, you can do this in any sort of tooling. And the pattern really is your basic container platform. We're going to build that module. We're going to push it to the container registry. But what's different about IoT workloads is really just this last step where we actually create the deployment and send it to IoT Hub. And what's really important here is where we actually, when we push that deployment, we define the target condition. So I'm not pushing it to this particular device. I'm basically saying, hey, if there's any device that has a property of environment that equals QA, it should have this deployment. All right, so that's really, as we go through all these different environments, that's the only thing that's going to change. So if we come back, oh, I should have shortcutted that. You can do it. Okay. So we create the deployment. We've got the thing packed. And so the next step is we're just going to do a smoke test. So really what this is, you'll notice it's not doing anything in terms of building. What it's going to do is actually deploy this to a container instance. So we're going to run, because again, it's a container. We can deploy this wherever. So we're actually going to spin it up in Azure. So we're going to take advantage of that cloud, give it the same parameters. We're going to dynamically create it and register it as a device and give it an identity in IoT Hub, which if you remember back when we were in VS Code and we saw this one here with just a name, it's completely ephemeral. We just spin it up, we test it, we destroy it. That's why it's blue, because it wasn't there. It's not there at the moment because this pipeline is finished. And then we're just going to run a smoke test script, which can be anything you want. In this particular case, it's just a simple script that checks, okay, are all the containers I expect to see on that device running? Is there a deployment in the IoT Hub that was targeted for this device? Is that exact deployment now running on this device? So we're not really testing the functionality of our code. We're really kind of just doing a smoke test to validate the deployment bit, so the manifest actually what we wanted to do. Once we've passed that,
and that's your custom script. Yeah.
Yes, yes, yeah. And I can show. Yes. Yeah. So, and that will really depend too on what your business logic is. You know, what does a healthy deployment look like? All right. So that could be things like, you know, can I read certain things from a thing? Can I send a message between these two components? Can I write to a database? I don't know. Whatever it happens to be. So the next one I'm going to do now. So I've tested the individual thing, but now we're going to actually get to do some integration testing. Right, so you could do this a number of ways. In this particular case, I've got a Kubernetes cluster running up in Azure, because again, you need a Kubernetes cluster, clearly. But the reason that is, obviously, I can deploy any number of containers. So what I actually do here is have I spin up a virtual device, and I can spin up as many of these virtual IoT devices as I want. In this particular case, I'm only deploying 3. But in the real world, if you wanted to it's great, it works in one. How do things perform when we have 100 of them running or 1,000 of them running? But it also means I can start to test this against other systems. And so this is really where that integration testing takes place. And that's probably about as far as we can go in the cloud. We're at the point now where we're as confident as we can be before we deploy it to actual devices that, touch wood, it's all going to be fine, relax, trust me. So now we're actually going to have to start deploying it somewhere. So in this particular case, what we're going to do is adopt a ring model. So what we're going to do is deploy it to what we call ring 0. So this is our canary cluster, or if you want to use that terminology, this is somewhere that's closely monitored. Maybe it's not running critical systems, or it's close to support staff, or whatever it happens to be that makes it a good device to deploy to first. In this case, this is my little blue Odyssey down here. And the deployment steps are all exactly what you've seen before. The only difference is in the deployment script down here, I've said, okay, this is going to be for devices that are tagged as production, but in ring 0. Okay, so that's just a property I've defined. And if we come over here and have a look at our edge devices, there we go. As well as the devices, we can see the deployments. So we can see here, here's all the different deployments I've created, and you can see here the target condition, and you can also see that for this particular one, so this was my kind of test deployment for these Raspberry Pis. So you can see there, they had to be in the dev, and the architecture had to be ARM32. If it met those, it worked. As soon as I did that, as soon as I plugged in my 3 Raspberry Pis, you see the IoT sub. Oh, there's 3 that match that, and it applied 3 of them. The same thing for those other environments we've done. So you can see here exactly which they match. So in this particular case, back here. So what we might, in this particular case, I then automatically go straight out to ring 1 wherever. So here I've said, okay, once that's done, we're going to go to ring 1 in the US and then ring 1 in Australia in parallel. And again, they just have the same different properties. In reality, though, we might not want that to happen because, we might want that to sit here in ring 0 for a period of time. So what we can do on each of these steps is we can, we can have preconditions and postconditions. So basically we can say, all right, we might need, let's say, an approval from someone before we go into that environment. So we can come in and configure that stage and say, okay, we need pre-approval from someone. And that might be 1 person or 10 people or 100 people. But what's probably more interesting, whoops, I should probably turn that off, is this concept of gates. So gates are a series of conditions that need to be met. So in IoT land, because we deployed modules down there that actually collected metrics on the host system, for example, we might define some gates that say, hey, ring 0, before you can leave there and go to the next one, it has to be deployed in that environment, and it has to not, the CPU can't increase by more than 10% because that seems unreasonable. We can also, though, call any sort of webhook. So we might say, oh, and by the way, we also want to go and check, have any ServiceNow tickets been raised against this Canary environment? Or, whatever you can think of, you can do. This is the exact model we use to roll out changes in Azure. So we do all those kind of things with metrics, but we even do some, bit of social evaluation and go, what's the sentiment of the tweets about Azure in Australia in the last week? If that's declined, don't keep rolling out. So whatever makes sense for your business, because obviously what applies in an industrial IoT setting is very different than, say, in a consumer setting, right? There's very different sort of metrics. But that's where this starts to become really powerful. And when you combine those two, so I don't know how it works where you are, but often, someone in authority is asked to approve one of these releases. What are they basing that on? So rather than just ask them to approve it, you can actually do all these other validations first, and the actual request that goes to them says, we want you to authorize this. here's the performance impact of this release, here's the things it fixes, here, whatever's appropriate. You can actually list all those out before. Starts to get very, very powerful. And if we go and have a quick look, so once they're down there and running in production, we can start to pull back all those metrics and all those sensors. We can deploy some of our security settings, security service as well. So we have if you've used Azure, you might have heard of Azure Security Center. The same concept exists down on the edge. So we can start to come down and manage our fleet, generate alerts, do all those kind of things. And again, the kind of virtuous circle here, I guess, is that, if security alerts are triggered, we might want to roll that deployment back if that's what triggered it. Come up here. So this is sort of our overall view of our environment. You can see loads, there we go, which are all orange, which is probably not surprising because these devices aren't configured in a production setting, but we can then start to drill in and see what those are. But apart from just being dashboards, any of these things are also, you can trigger alerts and do all those kind of good things. So in doing that, we've deployed all the way down to the edge. So let's just quickly jump back here and have a look. Mindful of time. Just touch on this one last thing. So apart from the rings, which we've sort of spoken about, so we can roll, if you think of them as a horizontal scaling out. In this particular case, everything could reach out through through my iPhone, because everything, I did forget to mention that. So everything we've done in terms of deployments and connectivity has been on 2 independent networks. I'm not connected to these devices at all, other than through the IoT Hub. So even the things I was doing in VS Code are going up and security controlled by IoT Hub. But in addition to that, we can also use what we call layered deployments. So what this, particularly if you're in an industrial setting, you've probably got a very segmented, compliant networking model. We can IoT IoT Hub can talk to an IoT Edge on the edge of the network. Again, handy name. But within the customer network, you might have nested layers of networks and security, and those internal layers actually don't go out to the hub. They actually just ask the layer above it. So these, if you're in a highly controlled, regulated environment, these nested ones will actually be pulling their containers from the layer above it instead of going to the cloud. So you can start to get really sophisticated with how you manage that. And we've kind of spoken about all that metric stuff. Cool. So the reason I kind of use that demo, there is I'll share this out on the link too, but there is everything you've seen in terms of all these pieces and all these things. There's a repository which is listed there, which is both a repository of all the code and a hands-on lab. You can go through and build this out. And also want to call out, there's some great MS Learn modules where you can, again, walk through all these step-by-step and put all this together. So on that, I'll pause there. How am I seeing, Michelle? Questions. How would you like to do questions?
So we have a Q&A going.
Awesome.
Yep. So
maybe if I can
2 questions from Tim. The first one is, can you do most of the things from VS Code and JSON YAML instead of using a browser? Yes. Yes,
absolutely, you can. So I didn't show YAML. I feel bad. Can't have a DevOps talk without YAML. Oh, there you go. There's some YAML. Yes, and that would be the idea. You can everything you can do in VS Code. So the idea is you would do your local development in VS Code and then commit that into your Git repository, and from then on, the builds are all everything is happening as part of the pipeline. You don't need to build it. And as you can see here, I had no connectivity to these devices, but I was able to go in, explore them. I can track telemetry. I can do all kinds of things. I can send messages to them. I can get them to send messages to me.
The pipeline was built in the browser.
Sorry?
The pipeline was built in the browser?
No. So I haven't got it open. Hang on. The actual pipeline, it's YAML. Okay. It's got to be YAML, right? You can build it in the browser. But if I go in here to this, and if I go in the browser and edit it, it's actually editing the YAML. So it's, whether you use the browser or edit the YAML directly doesn't matter. So all that pipeline we saw, this is the actual definition of it, which again is all version controlled and associated with the code. So yes.
Cool. If anyone has any other questions online, you can post them in the chat or in the Q&A function. I'm just going to throw into the audience to take a question in here, and then we'll come back to the chat. So anyone in here in the room? 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Got 24 people here and 15 online, which is great. No questions? Go ahead, go on.
I'm struggling to get this tangibly. What are you seeing your customers deploy in these containers? Realistically, are you seeing AI models being pushed out? Are you seeing just basic computation pushed out? What are you actually seeing in the field?
Yes, all of those things. So it very much depends. So
Just repeat the question.
sorry. So the question was, in reality, what are customers actually using this for? What are they pushing out with these things? So I know. So I'll speak from my personal experience. So I've worked with a lot of resource sort of companies, and they have very, very dangerous sites, right? So traditionally they've gone out and they've had monitoring solutions for industrial coolers and these things, but they're in rooms that are deadly to walk into, and so they've deployed this type of thing. So they can go, and if they want to go and change, they're connecting to their sensors using their existing infrastructure. So they're using traditionally, or mainly using quite legacy protocols. They're using OPC and all these kind of things. We haven't really talked about it as well, but the other use case for using the edge is as a translation gateway. So either as protocol or identity translation, all those kind of things. But at the most simplistic level, I see customers deploying it out so that their monitoring solutions can be updated dynamically without needing to go. They don't need to send someone out to the mine head or the oil well to do it. They can just manage it centrally. And that's kind of the base, that's your sort of basic remote monitoring solution. But once you start to combine that with, there's obviously your own custom developed AI, but more and more we're seeing, particularly in Azure, there's kind of off-the-shelf AI or cognitive services, which are really aimed at developers. It's not aimed at a data scientist. So a great example, there's one called the Anomaly Detection Service. You can literally take a container, deploy it, so your telemetry data goes through that module to detect anomalies and then goes up to the cloud. So you're not setting thresholds to say, hey, if it goes more than this or does that, it'll monitor that telemetry and will build up a picture of what normal looks like for that device. So if it's out in a harsh environment, it might perform very differently at night than in the day. So just crossing a certain threshold in and of itself isn't necessarily bad. So using something like the anomaly detection, it builds up a pattern and goes, hey, that doesn't match the pattern, and it can trigger an alert for someone to go and look at it. So that's just kind of like that step 1 to step 2. Whereas we've got other people who are using it, you saw in the healthcare examples, and they use that to deploy during COVID things to detect, are people wearing a mask, right? That's really easy to develop that AI model in a cloud service like Azure, but you need to be able to push it out and manage it on the edge. So the cloud, you just can't send video streams to the cloud. It's just not realistic. So they take that same model, push it to the edge, and all of a sudden it's being done, all that processing is being done locally, which was what my Cylon detector was using, although possibly far less useful. But it's that same idea, right? Take those services, push them to the edge, run the compute there, and only send stuff to the cloud you need to, be an alert or be it an image or whatever you want to do. So yeah, lots.
Has anyone else in the audience maybe used Edge in IoT deployments before and has an example of another use case? I see lots of nods, if that's okay. If you want to share, like, simple use case, go.
My one was deploying a classifier for an apple and a banana. That was my very first use case that I've done. Which is literally training. We have a service called Custom Computer Vision, and you can just pre-train the model using your specific set of images, so your own data set. So I've done it on my own set of apps. You can export it in that work with the same person that took the sort of display cells.
Do you want to summarize her use case for the audience?
Yeah. So again, it's that vision, custom vision service, and and I guess the thing with this is it's the flexibility of it. So if you've got data scientists who are doing all those scary things that data scientists do in the cloud, right? Because they've got that big compute, they can completely develop their own custom models from scratch using all the sort of open source technologies, and then package that up to execute on the edge. But equally well, you can take advantage of some of the Azure developer style services like Custom Vision, right? So it's a service where you upload a whole bunch of photos and you tag them to say, this is a this is a that, this is a that. And then it kind of infers that, and you can just take that and translate it back. You don't need to be a data scientist. Now, they're obviously going to do a lot more than what that will do, but it's those kind of low-hanging fruits, I guess. And that's where a lot of the stuff with the mask detection, for example, came from. Yeah, so COVID was a really good case where all of a sudden that stuff became really important. And yeah, you can build the AI model, but how do you get it into every camera? And again, obviously here we're doing Raspberry Pis because this is kind of what I do. But there's certified devices that have this built into it, and they're either industrial grade or medical grade, or it's just you're going to tap that, put it in your hospitals, and you've got a secure way to push that into those sort of spaces where you don't want people running around with a USB stick trying to deploy new software. It's just not a good idea.
We have one more question from the audience, and then we'll take a break, and you guys can ask any more questions to Todd in person before he has to go. So the question from John: I think that the continuous integration is YAML, but is it YAML for the release as well as in Azure DevOps?
No, not in this one. It can be. I did it both ways. So in Azure DevOps, you can there's sort of two models for deploying pipelines. So you can deploy them using YAML, or you could go in and use it's a separate GUI tool from there's these two models. But in this case, I had the CI as YAML and the release pipeline using the older GUI one. But you can define the whole release pipeline in YAML. Or you can do it in GitHub Actions or whatever you want to do, right? It's the model, I guess, is the important part.
Okay. There was another question from our friend Tim, but I've lost it. So Tim, post in the chat again.
Poor Tim.
I know, because the Q&A thing's pretty cool. If you've answered it, you can close it, and I accidentally closed it. Sorry. But yeah, we're going to have a quick break now for probably 10 to 15 minutes max, so 10 minutes. Everyone online, grab a drink of water. Everyone in person, also, we have water here. I just also want to call out over here, we do have a great audience in the room. We have had a female guest. Welcome. Welcome. I would love to see next time when we're in person and online some more females. 3 out of 5 of our speakers today are female, so that's a bit exciting. I challenge all of you guys to maybe bring a lady next time from work, or if you have daughters or nieces or partners or anyone you want to bring. Yeah,
for everyone, exactly. Michelle, so Tim has reposted his question, so I'll just ask it, and thank you, Tim. Does Microsoft have SCA and SAST tools for DevSecOps? Sorry, I didn't quite get it.
SCA and SAST.
Oh yeah, for DevSecOps, yeah. So I didn't kind of touch on that, but actually you may have noticed. So, did I get there? Part of any, it's not specific to DevOps. To IoT, but any kind of containerized deployment. There's definitely, security scanning and all those kind of things is definitely a critical thing. So we do have some services, but we also have partners. So your
it's late in the day, it's fine. You need some Pringles.
Sec and Twistlock, those sort of partners who are also available on Azure DevOps, you can put into the pipeline. So that's really helpful with the build time security. And then, as I mentioned, then for the, more for the runtime security, that's where things like Azure Security Center for IoT and Azure, get the terms wrong, Azure Defender for IoT, can both look after can detect, for example, if there's brute force attacks happening on the devices themselves, so nothing to do with the containers, it'll actually go and secure the devices, and it has all that intelligence as well, which, is a whole other topic. And I don't know if, so in the pipeline there, I didn't have a step for example, one of the, obviously here we're using lots of open source software, which is fantastic. But what if I'm using a library whether there's a known vulnerability for? And because I created this pipeline in the Microsoft tenant, even though I didn't have it, there was some steps automatically injected into the pipeline, because you can do that as a policy, to go and scan the open source code I was using to make sure there was no known issues with it. So there's a whole lot of that stuff, which is definitely good practice. And there's lots of good information on the Microsoft DevOps site about DevSecOps and the security thing. Not starting with not even just our products, just what is it, what do you need to do, and then showing how to do that. Definitely important.
All right, I might just jump into the video for a
Yes.
second. Can we give Todd a clap?
And my iPhone for sending all that telemetry for like 6 hours and not letting out of
this demo has been running for hours, and we've like pretty good battery life here. So thanks everyone for asking your questions. Are you going to hang around for like a minute?
Yes, I will. Yeah.
Grab a Pringle.
Yep.
Anyone in the room can ask some more questions, and we'll be back at 15:15. Does that sound good, Ali?
Yep, sounds great. We got some virtual clapping happening in the room here as well. So
Thanks, Trevor. I'll see you there.
we'll see everyone. We'll go into networking mode here in the virtual room, and yeah, we'll be back.
Yes.
Okay.
So feel free to jump along on different tables and meet new people if you're in the virtual space. Yeah, we'll see you soon.
Awesome.